Hello everyone, my name is Dima and my project is about quantum superposition. So I tried to find interesting topic and maybe a week ago I started watching a TV show. It's called Black Matter. So it's very interesting. It's about superposition that we can exist in multiple universes. So the superposition is one of the most fascinating and revolutionary concepts in modern physics. This principle lies at the heart of quantum mechanics, a field that has not only transformed our understanding of the universe but also paved the way of groundbreaking technologies in computing, communication, and beyond. So I will try to cover a little bit history and origins, what is superpositions, applications, and decoherence. So the story of a quantum superposition begins in the early 20th century at a time when physics were grappling with the limitation of classical mechanics. The inadequacy of classical theories to explain phenomena at the atomic and subatomic levels led to the development of quantum mechanics. Key figures such as Max Planck, Niels Bohr, Albert Einstein, Werner Heisenberg, and Erwin Schrödinger contributed to this revolutionary field. Erwin Schrödinger, one of the pioneers of quantum mechanics, devised a thought experiment to illustrate the perplexing nature of superposition. Imagine a cat placed in a sealed box with a mechanism that has a 50% chance of killing the cat based on the decay of radioactive atom. So, according to quantum mechanics, until we open the box and observe the cat, it is in a superposition of being both alive and dead. This paradox, known as a Schrödinger's cat, underscores the strangeness of quantum superposition and the role of the observer in the determining of the outcome of quantum states. So, what is the superposition? Superposition is a fundamental concept in quantum mechanics describing the condition in which quantum systems can exist in multiple states or configurations simultaneously. Classical bits can exist only in two possible states. Typically, it's 0 and 1. In contrast, because of qubit is a quantum mechanical system can exist in zero state, one state, and any state that is linear combination of 0 and 1. Mathematically, superposition is a linear combination of 0 and 1 and can be written as psi equals alpha 0 plus beta 1, where psi is the state of the qubit, 0 and 1 are the basis states, the computational basis states, and alpha and beta are complex numbers called probability amplitudes. The probability amplitudes determine the probability of measuring the qubit in either state when measurement is made. Importantly, the state of superposition can be maintained only while quantum system is observed. Once measurement the wave function of a quantum system in a state of superposition collapses into one of the basis states. For a concrete example of how this might work, if superposition could exist in everyday world, imagine that a coin that is flipped and lands on the table in classical mechanics, and in a everyday world as we know, if the coins ends up in a state of either heads or tails. In a quantum mechanical system, the coin could be both heads and tails at the same time simultaneously, but only until someone or something observes it or measures it. In this analogy, once observed, the coin would take on the state of either heads or tails. Applications and future prospect. Quantum superposition is not just a theoretical curiosity, has practical applications with the potential to revolutionize technology. One of the most promising areas is quantum computing. So, superposition is a fundamental attribute of quantum computing system. The information in ordinary computers takes the form of binary digits that can only have two states, 0 or 1. The superposition of qubits, as we said above, allows it to store 0, 1, and combination of both values simultaneously. Uh, so, quantum computing is currently the hottest topic among investors because this means it has incredible potential in terms of speed and efficiency compared to classical computers. Nevertheless, there is much work to be done before quantum computers hit the market. So, the next application is cybersecurity. Um, First of all, entanglement of quantum particles is a great way of improving cybersecurity. Enhancement of communication security with quantum protected cipher keys is possible when entangled atoms are used to detect whether something is interfering with data transmission, also calculating the factors of a very large number, let's say 500 digits, is considered impossible for any classical computer. The very fact that factoring in big numbers is difficult even for the best computers in the world today is the basis for present day cryptography. So, the next application is quantum simulators. In 1982, a famous physicist, Richard Feynman, proposed a simulation of quantum systems. It will allow us to understand the interactions between atoms and molecules. Quantum computers will provide us the opportunity to study quantum physics itself in a way that wasn't possible before. It may, for example, be used for modeling the drug molecule behavior and designing novel materials for more efficient batteries or energy. And even quantum teleportation transfer the information from one particle to its entangled counterpart is quantum teleportation. So the connections between entangled pairs of particles has a minimum amount of entanglement needed to successfully perform quantum teleportation. Researchers have performed many demonstrations of this, and by 2017, one of research group had teleported a photon from Earth to satellite orbiting. It's about 1400 kilometers overhead. So quantum teleportation is also the center of plans for quantum for a quantum internet. Decoherence, the challenge of superposition. A major challenge in practical application of a superposition is a decoherence. Quantum superpositions are fragile and can be easily destroyed by interactions with the environment, causing the system to lose its quantum properties and behave classically. Ensuring that qubits remain in superposition long enough to perform computations is a key obstacle in developing reliable quantum computers. Researchers are actively working on methods to isolate quantum systems and correct errors due to decoherence. And conclusion, as we delve deeper into quantum realm, principle of superposition continues to challenge our classical intuitions and expand the horizon of science and technology. The journey from the early 20th century discoveries to today's cutting edge researches highlights human curiosity and ingenuity. The future holds even more exciting possibilities, and quantum computers may one day solve problems in seconds that can would take classical computers millennia. So, quantum communication networks could revolutionize how we transmit information securely across the globe. Thank you.